So now that we're finished reading the key language, we're going to observe the learning log activities from page 120 to 122, okay? Take a look at these pages, okay? So check one by one, observe the images, observe the questions, observe the blown words that you see right there in the information. Observe everything, okay? So for this, I will give you 5 minutes for you can analyze it, make a scanning, and observe what are we going to see in this new subject, okay? Now, so let's observe this page 120. And I want you to take a look at the information that is located to your right. It's that green information that you have there, okay? So now this information, we're going to start by reading it. But before that, I want you to draw water boiling. Draw water boiling if you have your learning logbook. If you don't have your learning logbook, then it's okay, okay? Remember that to answer these activities, if you have your learning logbook, then do it in your learning logbook. If not, then do it on a white sheet of paper, recycled paper, or in an old notebook, wherever you're working on. So we're going to start by reading this information on page 120. That is this one right here that you observe, okay? And in this information says, the variations in the temperature of water when it changes state can be represented graphically. When water absorbs heat, it goes through progressive changes in state, which can be represented on a graph called a heating curve. This graph represents a sample of water that receives a constant amount of heat. So over here underneath, this is the graph that they're talking about, called heating curve. This is the heating curve. And if this heating curve, you observe on top of each letter an image that will be the representation of how the state of matter changes, okay? From ice cube smelting a little bit, you see water evaporates, and you see just water vapor, okay? So now let's observe that over here it tells you that from line A and B, so that means from line A and B, the ice absorbs heat, so its temperature rises. So this one right here is this one, okay? Line B, C, that means line B and C, fusion begins. During this time, there is ice and water. The temperature remains constant. Imagine yourself that you're going to drink a glass of Coke, because I know like everyone likes Coke, right? But this Coke, it's a little bit not too hot. It's like a worm, no? So you grab your glass of water, you grab a glass, and you put some ice cubes like you observe right here, okay? Later, you forget those ice cubes on the table, and you forget your glass, and you're like, okay, I'm going to turn off my bedroom's light. So you go turn on your bedroom light. You come back and you see that the ices are starting to be ice and water like it says over here. But the temperature remains constant. You still have the temperature of the ice and a little bit of water, okay? So now it says, so that means that line BC is this one, okay? Line CD, at point C, fusion ends and the temperature of the water rises. So that means right here, at this point, the water rises. There is only water in liquid form. The temperature remains constant. So right here, it rises, and there's only water on the glass. This is only water in liquid form, okay? That means that from C to D, right here, there is only water, okay? Now it says, line DE, the water starts to boil. The line from DE, the water starts to boil. Right here, you observe right here, look what happens to the water, okay? The temperature remains constant, okay? The water starts to boil. During this time, this is liquid and vapor. The temperature remains constant. So from here through here, you see a little bit of what? Of vapor and liquid, okay? So this is line DE, okay? Now it says line EF at point E, The evaporation ends and the temperature of the water rises. There is only water in vapor form. So from EF, there is only water in vapor form. Okay, you don't see water over here. If you notice over here, it's empty right here. Okay, so this one will be line, this will be line EF. Okay, now once we observe this image, let's continue on the next part. Over here is the first exercise that you have below this information that we just read. It says use your previous knowledge to fill in the following diagram, showing the changes in state. Okay, remember that on week 4 we also talk about this. We talk about deposition, sublimation, condensation, evaporation. We talk about all those concepts and what happens to the state of the liquid. It passes from solid to liquid to gas. Okay, so before we continue, we're going to do this exercise alone. I will give you 5 minutes to do it. Okay, and then we're going to come back and check our answers together. Okay, so ready? 1, 2, 3. Okay, guys, now that you finish analyzing and reading the exercise number 1, let's do it together to see if we have the same answers, okay? It says, use your previous knowledge to fill in the following diagram showing the changes in state, okay? So now let's start where it says sublimation, okay? No. Let's start over here when it says state. A state will, if it right here is liquid, there's two type of states missing, okay? Let's try to put this one as a gas, okay? So, let's try to put this one as solid, okay? Solid. What happens if there is sublimation? What happens to the state over here? So that means the state over here is gas, okay? So what happens over here from solid to sublimation and gas, okay? What can it happen? This is sublimation, gas, deposition, solid. From the state of solid to change it to the state of liquid, what is it? Yes, you're right, it's fusion. Okay? Now, from state liquid to change it to the state gas, what is it? You're right. Vaporization. Okay. Now, from gas to liquid, what is it? What is that process called? You're right, condensation. Now, from the state liquid to solid, what is that called? That process? Yes, you're right. Solidification. I don't know if it will fit. Yes, solidification. Okay? So now you see really easy how we fill in this diagram. You see the three matters: solid, liquid, and gas, the three states, and from solid change it to liquid, the process called fusion. From liquid to gas is vaporization. From gas to liquid, condensation. And from liquid to solid, solidification. This is a process of sublimation, change it to the state of gas, then deposition, then solid. Okay, so now let's continue. Over here you have this page 121. We're going to start, like always, reading and analyzing this green information right here located to your right. Okay, then we're going to continue and doing the exercises. Okay, so let's continue. It says a cooling curve of water represents the physical changes in the water as heat is released or transferred. This graph represents a sample of water vapor that transfers a constant amount of heat. Now, if you observe in the previous one, we saw heating curve, okay? How can heat transform into a gas vapor? Now over here we're going to see cooling curve, okay, of the water. How does it change? How is the heat released or transferred? Okay, it says line A, B. As the temperature of the vapor falls, the particles lose their kinetic energy and the vapor's volume contracts rapidly. A and B, so we're focused on A and B, and we observe that the vapor falls, okay, and loses the kinetic energy. You see right here, this is A and B. Line A and B. Now over here it says line B and C. B and C. This line. At this stage, the water is liquid and vapor. The temperature remains constant. So right here, if you observe this one, this line will be in vapor and liquid a little bit, okay? Line C and D, this one right here. At this stage, the vapor has condensed. As this temperature decreases, the liquid releases heat until it has reached the temperature of solidification. Okay? That means that over here you will have liquid or like water. Okay? In this part, the liquid, the gas or the liquid changes to solid. The liquid changes to solid, that is made solidification. Okay, the line DE, this line right here, at this stage solidification starts. Water can be in a liquid or solid form and the temperature remains constant. So right here you have water and at the same time you have in solid form. Line EF, line EF, this line right here, it says at this stage water can only be found as a solid, that is as ice. So over here at this stage you have ice. You see from cooling what happens if you put water inside a glass and you put it in the fridge. This is going to happen. This process will happen. The cooling curve, okay, is the process when you put water and you want to change it into an ice cube, okay. The other information that we read was heating curve. When you have solid and you want to change it into boiling water, change it into a gas state, okay. It says water expands when its temperature drops. Unlike the case of most liquids, this is one of the special properties of water. In effect, it causes the same amount of liquid water to have more volume and to be slightly less heavy as a solid. That's why when a lake or a river freezes, the ice, lighter in weight, stays on the surface and living things are still able to exist underneath. Okay, you see how a liquid can change into an ice, okay, depending on the situations. Now let's continue in the next part. Over here you observe this exercise, okay, that it says draw an example for each change of state that you come across in every day. Over here they give you an example, the lake and the river, okay, according to what it was saying. But over here you have evaporation, solidification, condensation, and fusion. You students, you have to draw, over here you have to draw a state that comes into your mind from everyday life. Evaporation. Does mommy likes coffee? Okay, yes. Well, when mommy puts coffee, okay, in a coffee mug, what happens sometimes with that liquid? It starts evaporating. So there's a little smoke or gas and you smell it. Solidification. What happens when liquid changes to solid? When in liquid, you put a glass of water and you put it in the fridge, solidification happens and liquid, the state liquid, changes into solid. Condensation. Condensation is when gas changes to liquid. You students think of a process that happens in your daily life. Gas changes to liquid. Well, for example, when you're in the shower and you're taking a bath and you observe the window that there's a lot of vapor, a lot of gas because the water is hot. there's a lot of gas, and at the same time you see like small drops of water that is liquid. That's condensation when gas changes to liquid. Fusion is when solid changes to liquid. Help yourself with page 100 with page 120, and this information you will find it there. Okay, page 120, you will find what is evaporation, what is solidification, what is condensation, and what is fusion. Okay, it's a diagram that we did, exercise number 1. Okay, so now for this activity I will give you 5 minutes. I hope you understand me. You have to draw examples of this stage, okay, according to your life experience. Okay, 5 minutes and then we check. Okay, guys, now time is up. Okay, from page 120, we're going to draw according to what you have. If you have different drawings from mine, then it's okay, don't worry. Many answers are possible in this activity. There's no right or wrong answers if you know the correct process from each state. Okay, if you know each state. Okay, but remember that for evaporation, I will draw for evaporation in this case. Let me think what I can draw. For evaporation is the same thing. It's when you change something liquid into gas. Okay? So in this case, it could be water boiling. So this is like a pot. This is water. This is water. And over here, let's put like this. Okay? Solidification is when liquid changes into solid. So in this case will be like a drop of water, you change it into an ice cube. Okay, liquid, you change it into solid. Condensation refers when you change a gas state into a liquid state. Okay, this is the backwards. This is when it's called the cooling curve. Okay, you have gas, you're going to change it into liquid. Well, the gas right here that you have will change into a drop. Okay, I'm doing the drawings really simple because I don't have space, but you have the time to do it, okay, more nicely with colors and more creative. Okay, use colors for these activities. Not just copy mine. No, don't copy mine. Do yours and understand it depending on the everyday life that you're living. Okay, fusion means when you change the state solid into liquid. Okay, that is fusion. Okay, when the solid, imagine the ice cube, it's in your gas, it's in your glass, okay, of water, and all of a sudden it starts what? It starts, those little cubes starts to melt and you have water. Okay, so that is the process of fusion. When you draw, you can draw something solid that is change it into liquid. Okay, so now let's continue on the other part.